Good evening, everybody. We'll just start shortly. One moment. Okay, before starting, please change the working directory. Okay. So, any doubts in the last class? Did you all go through the codes? Everybody? Are you all able to hear me?
Yes, sir.
Okay. Did you all go through the codes of the last class? Yes or no?
Yes, sir.
Okay. So last class we worked with the central limit theorem. So anybody can tell what is central limit theorems? Anybody? You can refer Google and speak. Any person? Any person? What is the central limit theorem? Anybody? Why you all are silent? Then just go through, open Google and check it out. What is the central limit theorem?
So Google says the central limit theorem states the distribution of samples means approximates at a normal distribution as the sample size gets larger.
Yes. So what is the simple meaning of that?
So the distribution of any sample is same as the will become same as the what sample size increases.
Yes. If the sample size increases, the mean will also change, right? It will also differ if the data if the normal distribution gets increased or increases, right?
Yes, sir.
Okay. So one picture I have got for you. Same from the Google only, you can check it out. So distribution of the sampling will be normal if it is in this manner. So it is, once it is increasing, you can see the distribution population is increasing. Okay, this is what is your central limit theorem. This is a part of your statistics. So that is why in data science is nothing but the statistics. If you statistics, at least the basics you know, it is very easy to understand the codes here. Anyway, the codes, whatever you're doing it is all based on the statistical theories. Okay, let us come back. Okay. So from the previous class, please load the data, mouse, Fino, CSV. I think everybody has this particular data. You can load it. Today also we will continue with the same central limit theorem, and also we will try to study the t-test. Okay, could you all load the data? Yesterday it was only last class data.
Yes, sir.
Okay. So then you can take this DPLYR for doing the analysis for this. So install package, install packages. The only limitation to R is that once you are closing it, even if there is an option for saving the session, this particular packages, it gets saved in the temporary folder. So once it is closed, this data sets, this packages may not be available. So it is always better to check it out before execution.
So there comes an option to save even background data, no, sir? Now if I type library DPLYR, it comes directly, sir.
You can check it. If it is there, it is okay. No need to always install it. If it is, that's why it will just, you can check out with the library command. If it is there, it will come. Got everybody?
Yes, sir.
Okay. So in the same manner, like the last class, do this control population and see. Last class we got stuck with this. Hopefully it is working for you now. I will put this code in the chat box. Check it out if everybody this code is coming. Yesterday we got, last class we got stuck, it was not working. So I had to stop it. Anyway, I had sent you the codes. I don't know if you have done it or not. Are you able to execute the codes today?
Yes, sir. It's working, sir.
Okay, great. Great. So today we will generate the histogram of this. Last day we had done the mean. Today we will do the histograms also and check it out. So try to execute these two histograms and check it out if it is working. So histograph of this HF population, yeah, it has worked, and histogram of the control population. In the control population, it is selected, the filter is given for the chow data, and in the HF population, it is given control as HF data from the data set. So now you can run this QQ norm plot. And check it out. So QQ norm, this one normal QQ plot you are running on the, first it is on the HF population. HF population, that is on the, yeah, the filter where you have selected the HF data. The diet is HF you have selected. Now you have to run on the control population. These codes are very simple. I think you all are understanding. It is the one line codes. Next we'll calculate the mean. After mean, we have to calculate the standard deviation, but without using the SD function. One moment, everybody.
Sir, if you're speaking, you're on mute.
Yeah, hello, yeah. I was on mute. Tell me. Could you get the mean?
Still doing, sir.
Okay. So mean of both the populations you can calculate. So these steps are similar to the last day, but from here the changes will come little bit. Bit changes. Here you will not be using the standard deviation function. So you are getting the population estimate, but in case if you are making the sample size just with reduction of -1, you will be getting the answer as true. Yeah. So here, what you have done it, you have calculated the deviation and variation without using the functions, this direct functions. So here you are using a different function that will be pop_var and pop_sd. That is for a different package. So here you have used pop_sd for the standard deviation. Okay. These are the commands. Why I am telling you here is, see, initially when you had done the data in an analysis, normally you had used directly the for the mean, as you had used mean and all the other mathematical functions, but for each and every particular package they have specific functions, so that you have to take a note of this. This roughly package, it gives the function as pop_var and pop_sd. So that is a little difference here from the last codes, from the last class codes. It is having the same functions of the sd and var. In this particular commands, what did you do? Anybody can tell? From the HF population, you have taken the 12th items, and even from the sample population. So as you have given the initial value as of n as 12, you can check it out by giving the HF what it is. You can check it out and you will see what it has taken for HF. Okay, same with the control. So now we will be using two different functions, sapply and replicate. For what? Just check it out. This is for a looping. Initially we had used for loops and on. Here we have used sapply for the loops. So you can see here one red color will be flashing because you have given us the 10,000 number of stimulations. Now you use this QQ plot and see this central limit, how it is coming. So here you are using the loop and you are creating the QQ plot. Everybody got this QQ plot?
Doing, sir.
Yeah.
Got it, sir.
Okay. So now you use for using the for loop, and here you are using the s with the sapply function. Again, you are creating the this one QQ plot or using the loop or within the loop. Okay. Actually, initially I did not get this four plots. I hope everybody has got it. Sometimes I don't know why my R got stuck. That is why I was
Yes,
thinking
sir.
why I am getting this only one plot and others plot two plots I did not get, and this was also incomplete. Okay, just my R got stuck. Okay, that is why I got this message. Time elapsed time liquid, because initially what happened was we had given the stimulations for 1,000, not 1,000, 10,000. So for the R it did not run within the time. That's why it got stuck. Here also you are giving the same number of stimulations. It will take a little time, and you will see the, I won't say same plots, it will be bit different plot. It will be with the quantiles. Yes. Got everybody?
Got it, sir.
Yes, sir.
So you can see how you are using the various statistical functions here in using a different with various different commands. First you used with the for loop, next you use with the sapply, and finally again with the same for loop, and you are getting the plots. Inside there are all 10,000 circles. If you know, it will be there, because we have given the stimulations as 10,000. So 10,000 circles will be there inside. But the plots, you have to check it out. What are the plots? It is coming based on the data which is fed inside. Okay. So let us move
Yes, sir.
on. Okay. Now everybody please read your female mice weight. It we had taken in the last class. You can take a different R script and do it. Yeah. Do you have this code? Do you have this data set, everybody? Everybody have this data set.
Yes, sir.
Last class I had given it. I don't know if you have saved it in your system.
We have, sir.
Okay. So in the same commands you can use, and you can make the data set of control and treatment, just like the last commands. In the last exercise, what you did it, it's a similar manner in the same data sets. Is control and treatment. So this here we'll be using the t-test. So what you have just now done, you have calculated the standard error.
So some errors coming. It's saying error in filter, problem while computing.
Yeah, that is same like last time.
What do I do, sir?
Use a different R script. Use a separate R script and check this particular library dplyr and check it out. Hopefully it should come. Got it? Did you get it? Alex?
I'm doing 1 minute, sir.
Okay.
Got it, sir.
Okay, this is the standard error. Already you have done it. You are giving it in a particular function, that is SC. SC is for standard error. Same thing. Whatever you have done it, you will get the standard error. Now it is t-test. So what is t-test? Diff divided by SE. This is t-stats, anyway that is the same as t-test. So what you have printed here, this is the p-value you have printed. This is your p-value. So as you know that if the p-value is smaller than 0.05, it is statistically significant. So whatever the data you have used, so for this you can check it out, it is less than 0.05, your data is statistically significant. I share the code, yes. So you are creating the QQ plot. Now you do the t-test for the treatment and control and check it out what you are getting. So the same already you have done the t-test, you directly without giving anything. Here you can give one variable to the t-test and check it out. So you have given as result equal to t-test, and then you are printing only the p-value. So like this also you can do it. So for the other data set also you can do the t-test. This data set what you are used is the female mouse weight. So the female mice weight. Here you can use the other data set, that is your mice pheno, and take the t-test. So got everybody? So complete statistics actually you can do using R. There is a, I think in your MSc there will be a part for computational statistics in the last module. So you can use SPSS or anything, but R is a better option because R you can handle even the large data. You can get the analysis using graphs, which is not possible in the other softwares. Got everybody?
Yes, sir.
Okay. Everybody got? Then we will move ahead with the confidence interval.
Yes, sir.
Okay. If you got it, we will go ahead with the, this one I will be saving as CLT, and next one is t-test. CLT. This is t-test. And the homeworks which I had given you, that was also on the CLT only, but that was only just on the population. CLT, but it was mainly on the population and the samples. Here we did the using all those two data sets. We did the CLT and t-test. Now we'll do with the go ahead with the confidence intervals. So read the data. Mouse pheno CSV. Make sure that you are using a different R script. You might land up in an error. And before that, please, we will be giving you the library. You have to execute it when the time comes. Okay. So calculate the mean. So here what you have done is you have taken a small sample from your job population. What is the population size you have taken? That is n equal to 30. So 30 population from the main population you have taken. That is your sample. I think everybody knows what is a sample in your statistics. From the big population, you are taking a small population and doing the analysis. That is called as a sample. So calculate the standard error. So SE is again the standard error here. So calculate the standard error. Then now you are defining the interval. The last few codes I did not send you. Okay, standard error. So you have got the interval. Check it out if your statement is correct. So you are getting it true, so it is correct. Now define the class, sorry, library. So check it out if this library is still functioning. So you are giving one that is b equal to 250. Then you are giving the plotting function. Got everybody?
Got it, sir.
Okay. So what you are given initially, n is how much you are given? Not, I won't say n, it was b it was given. So what was the B value?
250.
Yeah, now you can give a little less and check it out what happens.
It becomes less dense.
Yes. Got everybody?
Yes, sir.
Okay. So initially you're just used with the interval. Here you have specified the interval and you see what is the difference you are getting. So you can check it out. So QT and Q norm, which is bigger, that you can check it out. Now check the t-test of the confidence interval. This is the confidence interval here. You can change it out. You can change it by giving some other. Okay, I will just before I will do it. It is 0.9. You can give 0 and check it out. What is the difference you are getting? And 0.05. Okay. Got everybody?
Yes, sir.
Okay. So this one you can save it as confidence interval. Okay, shall I continue till 9 o'clock today? I don't know why there are today less people. Shall I continue till 9 o'clock today? Is it okay for all? Another 15
Yes,
minutes?
sir. Yeah,
Okay.
sir.
Okay, great. So let us go ahead with the power calculations. So read the data, mice, Fino, CSV, and check out the library. Get the control population like the last experiments and get the mean. So these commands are the same throughout. So control population, HF, mean. So all are getting any error? Anybody is facing again with the control population and HF population?
No, sir.
Okay. So take it in the percentage. Check out the t-test here and the p-value. In the t-test here, you are taking the p-value and going ahead.
So for me, errors come, sir.
Where?
The object sex cannot be found.
Please use the different art script
It's a new one itself, sir.
and read this library DPL That is the same error. Check out this library and use in a different, then it should have come. Did you use this different library, Alex?
Yes, sir.
Library and script. Change the script and again try to load the library. DPLYR. Because that is the only package you are using so far. Got?
Same error, sir.
Again.
Yes, sir.
What I can do. Did you load this package? Sorry, library. Is it running
Sure.
fine?
How do you check it's running fine, sir?
Hmm?
No errors came in error and library.
No error means it is running fine.
I'll restart R and check, sir.
Check it, yes. Because till this particular course, it is the same. The last you have used. Now you have to go ahead with this this one. Power calculation by checking the type 1 and the type 2 errors. So what is the power calculation here you are doing? It is you are rejecting the null when the null is false. That in the statistics there is there that when you have to reject the null hypothesis. But when there is a null hypothesis you cannot reject, then you have to go for the t-test. That is all, everybody knows it. So now check it, go ahead further. So reject the null hypothesis here.
So it's still the same. It's saying object SX not found.
Object 6 is not found.
It's saying
The
error in
ga-
filter and then cost by error object 6 not found.
Your data set is fine. The data set, just check it out. Try to read the data set. Just give DAT and check it out. Which
Yes, sir,
data
it's
set it?
fine. It's fine, sir.
Okay. Then what can be the error? After restarting R, did you run the library?
Yes, sir.
Try to install the package and then run the library. I hope that it should solve it.
I'll try, sir.
Yeah. Because this particular package only is creating the trouble. So you are rejecting the null hypothesis. So check it out which is rejected. If you are giving 12, check it out what is, if it is right or wrong. So So 12 is rejected. So check it out, which are the rejections. Do the mean for the rejections. Alex, what is the status?
Same problem, sir.
Same problem. I think your R is telling that you give me some rest. There is no, I cannot understand the error.
Sir, I think setting working directory once again may affect.
Setting working directory. Check it out, Alex.
Sir, but if working directory has a problem, then I won't be able to read the file itself. No, sir. Reading is showing no problem.
Just check it out and see if this working directory is fine.
Because sir, we have selected like new R script, right? In that we are doing this code. So maybe.
Okay.
No, it's not working. I said ran it again. And after setting. So I really think R doesn't want to work anymore today, sir.
Possible. That is also a possibility. Just I will the codes will be I will be giving you. Try to work it out. I will anyway stop you another 1 or 2 codes. I will stop it. You will try to execute it and let me know if it is working or not. Okay.
Okay, sir.
Okay. So you have done the mean of rejections. The last one also this happened and I had to stop it because I was not able to continue further. Today it has happened with you. Okay. It will work anyway. So now you can you are giving the power function. Power you are giving and checking the rejections. Now you have to plot it. Plot the power and check it. Anybody else is getting the error apart from Alex?
No, sir.
Okay. So you can see that you have got the plot with the type B. So for the power you have generated the plot. This is for the rejections. So initially you had given alpha, you had assigned one value for alpha. Initially that's 0.05. Now you can check the alpha and check it out the rejections. So here what you are doing? So you are changing the alpha and you are going further. Okay, so this is the plot for the alphas. So you are calculating the p-value. So now you are generating the p-values for what you had initialized it. And now finally you are plotting the p-values. So everybody got this plot? Everybody got this plot? Yes or no?
Doing, sir.
Okay. Now you can change this HF and see the difference. T-test you are calculating for the percentage. And finally you are creating a pooled standard deviation. So SD underscore pool will be the pooled standard deviation. Okay, if you have all got it, it's fine. For Alex, it will be a division. The codes are very simple. You can try to understand while you are executing it. Got everybody? Yes or no?
Yes, sir.
Okay. So for all this today, I created this this one confidence level, t-test, intervals, and power calculation. Please try to execute it with the data sets which I had given you initially. Alex, if you are getting any error again, please let me know.
Okay, sir.
Okay. Any doubts? Shall I end the class here today?
Yes, sir.
Okay, then. See you all. Good night.
Thank you, sir. Good night.
Good night.
Good night, sir.